Okay, so we know that the ability to produce a high ratio of forces during early acceleration is important for performance. And this was based on the average ratio of forces over the initial push-off or block exit and the first four steps. But what we wanted to understand now is what are some of the priorities around how you achieve this high average ratio of forces? Is it more important to get a really high initial value in that first push-off? Or is it more important to try and stop the decline in ratio of forces and maintain reasonably high values as the early acceleration phase progresses? So what we were looking at here was what should the priorities be for an athlete when trying to achieve high average ratio of forces in the early acceleration phase? If we look at the relationship between RF0, so essentially where our RF velocity linear relationship crosses the y-axis, we can see some reasonably strong relationships here for both the block starts and the standing starts between RF0 and between our performance measure, the average horizontal external power they produced over those exit and first four steps. And then if we look at the relationship between the slope of our RFV line, so the DRF measure and performance, we can see some weaker relationships between these. But actually what was really interesting was when we looked at both RF0 and DRF, and remember these are all calculated from direct measures of these things from the force plate and using the step average forces to obtain them, as I showed in one of the earlier videos. When we calculated those and put them both into a multiple regression to determine performance, if we start here with the RF0 relationship but rotate this round in 3D, we can see actually that these data points lie very much on a plane as it just rotates round here to the DRF relationships that I showed in the second slide. So I'll rotate it back. So actually, over 90% of the variation in performance was explained by the combination of these two measures. And what was quite interesting when we looked at the results of the regression, it appeared to suggest that essentially the ability to have a high RF0, so a really high y-intercept on that line, was what the athletes should initially prioritize. That was the more important variable for higher levels of performance. And when athletes could get that high RF0, only then did trying to arrest the drop-off in ratio of forces, the DRF, become important. So this is only from a cross-section of sprinters, both from block starts and from standing starts. We don't know about how changing these variables through training would affect things, but this has been quite nice, hopefully, to demonstrate that that ability to generate a really high initial kind of horizontal component to our force production is key. And then if we can achieve that, you really should be striving to try and maintain that for as long as possible in those first few steps and prevent the drop off in that horizontal component.